Okay, let's do some quick review of things about slope-intercept form, slope, parallel and perpendicular lines, things like that. So most of this should be something that's a review that you did in Algebra 1, Geometry, probably in Algebra 2 just a little bit as well. So what we're going to look at first, and this is section 1.3, is we're going to talk about how to find slope. Oops, daisies. How to find slope. And basically if we find slope given a graph, that means that we are going to use m as slope. We're going to use our change in y, goes in the top. Oh, excuse me, that's the next thing. Sorry. If we are given a graph, we don't need to do the change in y and the change in x. We can just count. We can count rise, which is up and down, over run, which is left and right. So if we are looking at our graph, going from one point to the next point, we are rising a positive 4, and we are running a positive 5. So our slope in this case is going to be 4/5. Now, given 2 points, here's how we find the slope. That's what I was getting ahead of myself there doing. If we want to know the slope and we're given 2 points, that's when we are going to subtract our y's on the top. That's like our rise, up and down. And then we're going to subtract our x's on the bottom. That's like our run, left and right. So if we were going to find the slope of the line containing those points, we're going to say, all right, here's my x's, here's my y's. We're going to subtract our y's on the top. So I'm going to say negative 13, that's y number 2, minus negative 17 on the top. And then our x's, if I did negative 13 first, I've got to do 11 first. So I'm going to have 11 minus 5. So I'm going to subtract my x's. Negative 13, basically that's the same as plus 17 is going to be 4. And then 11 minus 5 is 6, and that will simplify to 2/3. And slope is always going to be a simplified fraction, never going to be a mixed number or a decimal. Second thing, again, slope-intercept form. We've done this in every single math class, I think. M is our slope. We just talked about how to find our slope, rise over run, or change in y over change in x. And then B is our y-intercept, and that's where it crosses the y-axis. Okay? So we're going to write the equation of the line with a slope of 4, so that means our m equals 4, and through the ordered pair 5, negative 2. So 5, negative 2 means that our x value of our equation is 5, our y value is negative 2. So if we're using slope-intercept form, y equals mx plus b, we have 1, 2, 3 pieces of information given to us, and we need to find the fourth. So instead of y, we are going to put in negative 2. Instead of m, we're going to put 4. Instead of x, we're going to put 5 plus b. Negative 2 equals 20 plus b. We're going to subtract 20 from both sides, and we get negative 22 as b. So our equation in slope-intercept form with a slope of 4 and an ordered pair of 5, negative 2 is going to be y equals, our slope is 4, so we have 4x, and our y-intercept is negative 22. Okay, along those same lines, we have given 2 points instead of a slope and a point. So the first thing that we are going to have to be able to do, so step 1, is we are going to calculate the slope. And again, we're going to do that with our formula. We have 2 points, so we're going to subtract our y's on the top, and we're going to subtract our x's on the bottom, which means our slope is going to be y2 minus y1. We're going to have 1 minus negative 3, and we are going to have 4 minus 2, which means 1 plus 3 is 4, 4 minus 2 is 2, so our slope equals, as a simplified fraction, is going to be 2, technically 2 over 1, if we wanted to write it as a rise over run. Step 2 is we are going to find our y-intercept, which is b, using one of the points and the slope. So we're going to find b using one ordered pair, and the slope we just found. As I'm looking and trying to decide which ordered pair I want to use, I'm going to use 4, 1 because they're both positive. It should not matter which one you choose to use. But again, we have our y equals mx plus b. Right now we know our y is 1, our m is 2, our x is 4, and our y-intercept is what we're finding. So we would have a y-intercept of -7. And then step 3 is to write our equation in slope-intercept form. And I'm going to call it SI for slope-intercept form. Like so. So we're going to have y equals, we found our slope to be 2, y and x are always in our equation, and then our y-intercept is -7. So those 3 steps, if it's given 2 points, is how we're going to write the equation. All right, next thing, again, it's a little bit more review here, is that we have parallel and perpendicular lines. Parallel lines, if you have 2 lines and they are parallel to each other, they have the same slope or equal slope. Perpendicular lines have the opposite sign. So if the original slope is positive, the perpendicular one would be negative, but vice versa. And they also have the reciprocal slope. So 2 things with that. So like if our original slope was 3/4, perpendicular to it would be the opposite sign, which is negative, and the reciprocal, which is just the flip. So we need to decide, are these lines parallel, perpendicular, or neither? So to first, we're going to put them into slope-intercept form, which basically means we're going to solve for y. Okay, so I'm going to subtract 5x from both sides, and I get 2y -5x plus 10. If I divide everything by 2, I get y equals -5 halves x plus 5. So my slope over here is -5 halves. On the other side, now I'm going to add 4x to both sides. I get 10y equals 4x plus 30. If I divide by 10, divide by 10, divide by 10, 4/10 simplifies to 2/5. X plus 3. So our slope over here is a positive 2/5. Opposite signs and reciprocals, these are going to be perpendicular. Okay, so let's take a look at another one here. Okay, so we've got our first equation. Again, we're going to put it in slope-intercept form. -2y, we're not going to lose that negative out in front. And we are going to have -3x plus 6. Divide everything by -2. We have y equals positive 3/2 x minus 3. So our slope over here is positive 3/2. On the other side over here, let's take a look. We're going to add 6x to both sides. 4y equals 6x plus 4. Divide by 4, divide by 4, divide by 4. 6/4 simplifies to 3/2. 4 divided by 4 is 1. Over here, we have a slope of 3/2. And our slopes are both 3/2, so those are going to be parallel. Okay, next thing. Now, we have to find the slope-intercept form of the equation of a line that is parallel and perpendicular to the given line with the given point. Okay, so first thing is we're focusing on slope-intercept form here. So let's get that equation in slope-intercept form first. So we're going to subtract 2x from both sides. -3y, -2x equals plus 5. Divide by -3, -3, -3. So our equation in slope-intercept form that we're going to use is y equals positive 2/3 x plus we need to find the new y-intercept. So really the fact that it's -5/3 doesn't matter, because if it's parallel, it's going to have the same slope but a different y-intercept. So we have an x and a y here that we're going to use. Here's our x value, here's our y value. And we have our slope. If that is parallel, our slope is going to stay the same. If it is perpendicular, our slope is going to be the opposite sign and the reciprocal. So if we would need it to go through the point, so we're going to go, again, y equals mx plus b. If we need it to go through 6, 5, instead of y, I'm going to put 5. Our slope is 2/3 because it's parallel. Our x value is 6. Plus, we don't know where it's crossing the y-axis just yet, so that's what we're figuring. 5, 2/3 times 6 is 4. If we subtract 4 from both sides, we get b equals 1. So the line parallel to it is going to be y equals 2/3 x plus 1. If we are going perpendicular over here, again, we're still in that y equals mx plus b. Our y value is still 5. Our, equals, our slope this time is -3/2. Our x value is still 6, and we need to figure out where it's crossing the y-axis. -3/2 times 6 is -9, plus b. If we add 9 to both sides, we get that b equals 14. So now we're going to write in perpendicular. We're going to keep that perpendicular slope, 3/2 x, and our y-intercept is going to be +14. Okay? Last thing is just looking at how you can actually apply it to somewhat real-life scenarios here. As a linear equation, if you're buying a treadmill brand new from Scheels, it costs $5,000, okay? And the average life for a treadmill is 10 years. After 10 years, it's worth $400. So we're going to write an equation in slope-intercept form to model this, and then use that equation to figure out how much that treadmill is worth if it's depreciating at that rate after 7 years. So in order to do this, we're going to do the same thing that we've done before. We're going to use our slope-intercept form. Okay, and we need to figure out what our slope is. At what rate is that treadmill actually depreciating? Well, in order to do that, we need to have 2 ordered pairs, right? Which means our first ordered pair is going to be when we initially buy it. At the beginning of time, or when we bought it, at 0 time, our treadmill was worth $5,000, okay? After 10 years, so time is 10 years, is now worth $400. Which means we have a slope that we can find. So our slope is going to be m equals change in y, so we're going to have 5,000 minus 400 over 0 minus 10. So our slope is going to be 4,600 over -10, which simplifies to -460. Essentially what that means, every year the treadmill depreciates by $460, okay? So then we're going to say, all right, I've got my equation is going to be y equals, my slope is -$460 per year. Well, my y-intercept, if we think about the definition of a y-intercept, the y-intercept is the value. Remember, this is the value of y when x equals 0. Well, we have that ordered pair, so we don't even need to figure out what the y-intercept is. It's given to us. So we have 5,000. So basically, this -460 tells us at what the rate is that it's depreciating, and then the other number tells us what we started as a value for our product. So if we wanted to know after 7 years, that just means that we would put in 7 for x. And that would be -3,220 plus 5,000. So after 7 years, the treadmill is going to be worth $1,780. So we have our equation, and then we answered the question of how much it's going to be worth, and we did that with our 2 ordered pairs that we got out of our story problem, things like that. So you are going to have a WebAssign, oops the daisies, 1.3 WebAssign that you need to complete when you are done.